skeletal system lecture is on joints. What we're going to cover is the classification of joints. We're going to focus on synovial joints, and then we will briefly discuss disorders of joints. Now, you guys might have heard of the nursery song about how the bones are connected. So here's a clip of that nursery rhyme.
The toe bone's connected to the foot bone's connected to the ankle bone's connected to the leg bone. Now shake them skeleton bones. The leg bone's connected to the knee bone,
So you get the picture. So now the question is how? How is everything connected? The answer is joints. Joints, or they're also called articulations, is basically the site where two or more bones meet. So how all your bones are connected are through joints. So let's talk about these joints. We have different types of classifications of the joints, and they occur by either the function, which is how do the joints allow for movement. For example, the first is synarthrosis. These are joints that are immovable. Basically, a bone connects to another bone and they cannot move. Second, we have amphiarthrosis. This is where the joint is slightly movable. And third is diarthrosis, and this joint is freely movable. We'll give some examples of these later. The second way we can classify joints is by the structure, or what material they're made up of. One, we have fibrous joints, made up of a lot of fibers. Two, cartilaginous joints, and as the name says, it's made up of cartilage. And three, something called a synovial joint, and we'll spend a lot of time in this lecture on synovial joints because it's very complicated with the structure and the material it's made up of. So let's look first at the classification of joints by structure. So let's start off with fibrous joints. Like I said, it's mostly fibers, so it consists of dense fibrous tissues, and these joints are synarthrosis. Remember, that means that they are not movable. For example, the first type is sutures, and we've seen sutures before. You'll remember them in your skull. Recall we looked at, for instance, sagittal suture, frontal suture, squamous suture, and lambdoid suture. So these sutures will join together bone. So all of the sutures of the skull will join together the skull bone. Now think about it. If I asked you, can you move your bones with your sagittal suture? No, of course not. So again, the sutures, which are fibrous joints, are immovable. They cannot move the bones. And again, immovable is synarthrosis. Another example of a fibrous joint is called syndesmosis. Syndesmosis are joints that are held together by a ligament. So here we're looking at the end of the tibia and the end of the fibula. So you can see the medial malleolus here and the lateral malleolus here. So there's a ligament right here that's holding your tibia and the fibula together. And so again, this is a syndesmosis joint. Now you won't be able to move your tibia and fibula with respect to each other because this ligament is immovable. The third type of fibrous joint is gumbosis. And you can kind of see in the name gum, this is actually at your gum. The only example of gumbosis joints are with your tooth. So where the tooth basically sits in the socket in your gum. That's a gumbosis joint. Gumbosis literally means peg in a socket. So that's your tooth in the gum. All right, let's look at cartilaginous joints. Cartilaginous joints consist of cartilage, and they are not diarthrosis, meaning that they're not freely movable. Some of them are synarthrosis, you cannot move them at all, and some are amphiarthrosis, which have a little bit of movement. So we're just going to look at two types today. The first type of cartilaginous joint is called a synchondrosis joint. And this joint is made up of hyaline cartilage. So we've actually seen these before. For example, epiphyseal plates, right, between the epiphysis and diaphysis of long bones. The epiphyseal plates we know are made up of hyaline cartilage, and that's the synchondrosis joint. Another example is where the sternum meets your first rib. You can see right here, this is the manubrium of the sternum, and that's your first pair of ribs. And then right there is that cartilage. Remember that costocartilage. It's hyaline cartilage, and it's joining the sternum to the rib. The second type of cartilaginous joint is a symphysis joint. And we've actually seen an example of this. They are made up of fibrocartilage, and one place you see it is in between your vertebrae. So right here and right here, called the intervertebral disc. That's made up of fibrocartilage, and that's the symphysis joint. Another example is the pubic symphysis. So the pubic symphysis, you'll recall, joins your two hip bones together at the front. And remember, when we talked about the pubic symphysis, it's slightly movable. You can't move it a lot, but it's slightly movable. For example, for women, when they go through childbirth, the pubic symphysis can move slightly. Right. Our last type of joints we'll talk about are the synovial joints. Synovial joints are basically all the joints of your limb. The synovial joints consist of bones, and the important thing is these bones are actually separated by a fluid-filled cavity. And again, they are diarthrosis, meaning that they're freely movable. So we're going to look at the structure of these synovial joints, what this fluid-filled cavity looks like, which allows for this freedom of movement. So these are the joints that allow you to bend your arm, move your wrist, write, walk, all of these major movements you see in the limbs of your body. So let's take a look at a synovial joint. The structure of a synovial joint includes main things such as 1, articular cartilage. Remember, that's the cartilage you see at the end of the bone right here. It's hyaline cartilage shown in blue. So for instance, if this were a long bone, this would be the hyaline cartilage on the outside. 2, the joint cavity, that's the space right here between the two bones. 3, the articular capsule. So the articular capsule is actually right here, is basically the membrane that's surrounding the entire cavity. So in this capsule, you have what's called the synovial membrane. Remember we talked about membranes earlier in the course. We talked about, for instance, cutaneous membrane, which is your skin, mucous membrane, and one of the important membranes are the synovial membranes, and they come up specifically in these synovial joints. So again, this is the membrane that's lining the joint cavity all the way around. Now, the important thing about the synovial membrane is that it actually secretes synovial fluid. The synovial fluid is important because that's the fluid that actually fills up the entire cavity. So the entire cavity is not empty with air, it's actually filled with the synovial fluid. And then finally, because these joints move so much, you have ligaments on either side, here and here, which help stabilize the joint. Okay. So we have a true or false question. So think about people who are double jointed. Do you think this is true or false? Double jointed people have less stable joints. So this is actually true. What happens is with double jointed people, they can move their bones quite a bit at their joints. Right? And that's why they can bend their arm, their fingers in many different directions. So their joint is more flexible. But unfortunately, with that flexibility, it's less stable because they can't hold their bones in place as well. It's not as stable and strong of a joint. So although they're double jointed, they're more flexible. Unfortunately, what that means is that these bones can come out of alignment easier because, for instance, the ligaments aren't as tight and as stable. And so they're more likely to dislocate one bone from another. So we've been talking about synovial joints, and we know they offer a lot of movement. So with this movement, you can imagine the bones are moving a lot. They're causing a lot of friction on each other as they move. So we have to have structures that help cushion against this movement and friction of the bone. So these two structures I'm going to show you here are going to help with this. So first we have the meniscus, or called the articular disc. So what we're looking at here is the femur on the top, the tibia on the bottom. You're looking at a lateral view. So here's the patella up front. Right in between here, we have the meniscus, or the articular disc. Notice it's between the femur and the tibia. That means when you walk, it's going to help cushion at the synovial joint, so that way the femur doesn't hit and pound on the tibia as much. The second structure you have that helps with the movement of the bones and the friction is the bursae and tendon sheath. So right here, what we have, bursa is basically a little sac, and you can see in yellow inside, you can guess what that might be. It's fat. So bursa is basically like a little fat sac that sits between your two bones here and helps cushion it. So what we're seeing here is actually the humerus, the head of the humerus, and over here we're seeing the scapula. And we put that little bursa in between to help cushion, so that way the humerus doesn't directly touch the scapula. Tendon sheath is over here. Tendon sheath is shown here in green. And what it does is it's basically a connective tissue covering around the ligament. So this would be a ligament. If you think of the ligament as like a hot dog, the tendon sheath would be the bun around it. And again, that's just to protect the tendon. It's the sheath around the tendon. So that way the tendon doesn't rub on the bone. If the tendon directly rubs on the bone, it's more likely to wear down and tear. So you put that tendon sheath, which is that protective padding or coating around it, to prevent the tendon from tearing.